Really? Wow. Did not know. Okay, class. I'm recording here. This is fun. So I'm going to go like this, and I'm going to go like this, see if this works. Okay. So class, we are in 3.2. So I'm going to just do these notes here. This is called the product. Ooh, there's some stuff in the way over here. Oh, let me write it like this. Anyways, good morning, students. I am feeling a little sick here, so I figured I should not come in today, but I still wanted to give you a lecture, so we should still go on with calculus. So it's called the product and quotient rules. Got two extra rules added to what we've done so far. So now the question is, what have we done so far? Well, we've learned that the derivative, similar to this, the derivative of a constant, we'll put brackets, it's easier. So derivative of a constant, we say is zero. Is that true? True. We learned that last time. All right, the derivative of x, just the identity number x, that's a 1. The derivative of anything that has an x next to it. Let's see, a c times x. That would be a c. Let's see some more here. The derivative of a linear function, because remember, derivatives are just slopes, right? So if you have a linear function, mx plus b, that's just going to be m. That's easy enough there. All right, and then we had this little rule that we looked at. So if you have the derivative of a power function, so you have x to the power of n, that was from Monday's class. We have a little rule that says you can do this now. Super easy now with that. And then we have some rules, the fact that we can add, subtract, or pull out constants of derivatives. And so just a quick review of that. Just looking back real quick here to see. So let me write it just so we have everything in front of us. We just said this, the derivative of a function f of x plus g of x would be the derivative of the f of x function plus the derivative of the g of x function. So I can scoot derivatives through a plus sign. I can also scoot them through a minus sign. So I can do that. And it's the derivative of g of x. Okay. All right, one more that I was not able to put on here. And it kind of stems from this one right here. If you have a derivative and you have a constant that is multiplying x, what you also can do is you can set up that constant outside and then just take the derivative of the x function. And then we know, oh, hold on, we know that c is going to be here because c is just c, right? And then notice that we have this one, the derivative of x is just 1, so c times 1 is just c. So we have that. So we can pull a constant out of the derivative function. So constants can be pulled out. That's cool. Okay. That's pretty much all the stuff we covered on Monday. So let's jam. Let's do some practice problems from Monday. So let me do that here. So exercise 1, just to get us going. Find the derivative. That's all it is. Find the derivative of this guy. I'm going to put f of x is equal to 15.5 or 0.855. Right, I'm going to put this one as y is equal to 2x plus 4. And b, I'm given functions in kind of different variety of terms here. That's all, just so we have that. And this one, I'll call f of x is equal to x squared. plus 7x minus 14. All right, take the root of those if you can real quick. It should be super easy. All right, and again, the way I marked that this is a derivative now, I put accent mark right there. And this guy derivative is 0 because this is a constant. There's no x termed next to it. There's no nothing. There's just that. For this one, the way I say derivative is I put accent mark on the y. And the derivative of 2x plus 4, well, the derivative of 2 times x would just be 2. And this guy becomes a 0 because the derivative of constant is 0. So there it is. Derivative of y is just 2. All right, and the last one here. So the derivative of this guy would be power function. It's 2 goes in front. X, and it's going to be 2 minus 1, or just 1. This guy becomes a 7. This becomes a 0. We don't even need it at this point. Okay, I forgot one more. I forgot one more that we did the other day, which is on Monday, which is this one right here. Do you guys remember what is the derivative of e to the x? It's the only function in calculus which is a derivative of itself. So e to the x has the funniest property. There it is. It is its own derivative. So if you see something like that, just take derivative of e to the x, and that's it. So let's practice a little with that as well. So d, a, b, c, d. Yep. D, and let me look for a good one. Okay, x to the third plus 3 e to the x. All yours for that. Actually, I don't like putting the same numbers here. 1 second here. Let me. Yeah, there you go. 4. Okay. So what would be the derivative of this guy? So that's a power rule. That becomes 3x squared plus, and there it is, derivative of 4 e to the x. The derivative of e to the x is just e to the x, and the 4 just stays there. So it's just that right there. That is a derivative. 4 is a constant. You can move that in front and just kind of do it as a multiplier later on. So all that. All right. And let's do this here. Let's try some tougher ones, a little bit off the homework. E, or very similar to the homework. Can you guys give me this one? What's the derivative of x to the negative 3/5? Now on your homework, it's x to the negative 2/5. I'm just changing things up just a little tiny bit. All right, the derivative would be, it's a power function still, it goes in front as a negative 3/5. X is here, and then what we've got to do is we've got to take that, subtract 1. Technically, it's this, subtract 5/5, which makes negative 10/5, negative 8/5, sorry. And there it is. You can keep it like that if you like. You can change it so that we don't have any negative exponents, and you can keep it like that. That's fine. That's, both of those are actually okay terms to have right there. All right. Let's go with F. Oh, let's see, something similar to the homework here. Yeah, let me do this one here. Let's see, F, capital F, X. That's okay, just the name of a function. This will be 1/2 x to the third power, like this. So now notice, whoa, there's actually 2 different functions here. There's a 1/2 x, which is actually encapsulated into a x to the third. So if we're going to the rules here, we actually have no rules for functions within other functions. Sorry, not yet. So what we have to do is we have to do some algebra, and we're going to do this first. So 1/8 times an eighth times eighth become, oh, sorry, a half times a half times a half makes 1/8. and x to the third. Now we can take the derivative of this guy. So now we can go. All right, the derivative is, it's a power function. 3 goes out in front, multiplying the 1/3. So this is 1/8. And then we subtract 1 from the 3 to make it 2. There it is. There's my derivative. And again, very similar to a homework question. All right. And maybe to the next slide here. This one, G. Okay, and then this one I think may have given you guys a little bit of trouble, but we'll see. A over y to the fifth plus b e to the y. So yeah, looking at this one here, that's supposed to be a 5 right there, 5. All right, weird looking one. There are no x's here. There are y's. So you assume like, y probably is my variable. So there's that. And z is actually taken away from there here. So it looks like this. I'm going to put z prime, back mark here. And I'm going to have to take a derivative. Okay, the only thing is I got to simplify this just a little bit here. Let's do this here. I'm going to move this y to the fifth to the top. Oh yeah, by the way, a and b are going to be constants for us. Those are just constant terms. Think of them as a 12, a 7, or whatever. So now this guy's a power function. So I do take the -5 in front. So -5a y to the -6. Remember, because I subtract 1 from the exponent to get to my derivative. And then b e to the y, that's just going to be b e to the y. Okay, and then to simplify that probably just a little bit here, probably it would be a -5a on top. And then the y to the 6, y to -6 goes down to the bottom. And I have something that looks like that. That would be the derivative of g. Okay. All right, and last one here, h. And again, these are very similar to your homework questions. So I want to take a derivative of this guy, but real quick here, we have no rules for quotients. Oh, we're going to learn them today. We have no rules for quotients. So what we do is we have to simplify this some more. So x to the second over, technically this is now x to the 1/2, right? And we're going to split them off into each of the different pieces here. All right, the simplified version then it would be 2 minus 1/2, or technically this would be a 4 over 2 minus 1 over 2 makes 3 over 2. This is a 1, or technically 2 over 2. 2 over 2 minus a 1/2 makes another 1/2. That's a 5. 5s are not looking fine today. And then this one just kind of gets to go on top. This is 8x to the -1/2 now. I think I'm ready for my derivative then. I'm going to take the 3/2, put in front, x, subtract 1 from them, from that. So technically 2 over 2 makes a 1/2. Plus, then I'm going to go take a 1/2 of 5, x to the -1/2. And this was going to be negative, oh, hold on, 1/2, -1/2 times 8. 1/2 times 8 was a -4. X to the -3/2. Because again, I'm taking 1 away from that. And that's fine to have it like that. Maybe something looks like that. Let's do this. Let's take this down to the bottom because it has a negative next to it. So this would be 5, 2 to the negative. Whoa, whoa, whoa. That's weird. They wanted to get back into it. Okay. That would be change it to x. So this would be x to the 1/2 minus 4 on top, and I got x to the 3/2 on the bottom. Okay, then remember, a half is really just the square root. And this one's a fun one because there's 3/2. There's a full functioning perfect square that goes on the outside and one that goes on the inside. Okay, at least I took care of a little bit of the homework questions. Hopefully you guys looked at. And we will take a look at any others on Friday. But now we want to get to something called the product rule. So, product rule. And it says this. In fact, let me write it what students do think it is, and then we'll write it the correct way. So, what is the derivative if you have two things that are multiplying together? You have one function here times another function here. It's like how do you take a derivative of two functions multiplying? And so it is not, real quick here, it's not going to be this. You don't just take the derivative of the first times derivative of the second. It does not work that way because remember, we are interested in figuring out, okay, what's the slope of a line that has two things that are multiplying together? That's what we're trying to find out. Okay, so let me give you the product rule the correct way here. The correct product rule is it is f. It's the way the book has it. So let me write it the way the book does it. It's the function. It's the first function by itself. And then what we do is we take the derivative of the second function plus, then what we do is we have the second function and the derivative of the first function. Whoa, that seems really crazy here. Another way to write it is like this, maybe easier way to write it is first function, then we have g prime, then we have g, and then we have f prime. That's pretty crazy. Okay, let's see if we can work with this. All right. Exercise 2, find the derivative. And this is all about trying to figure out the slope of a function. And that's all it is. Okay, so talk to me. I need you guys to find the derivative of x e to the x. Notice those are stuck together. Is that right? Okay, so there's a few things that are happening, and I want you to guys to figure out. So my f function, right? That's my label of my function. Right? As far as the formula goes, that we just did on the other side, that's my sort of like little f function, and that's my g function for my formula's sake. So kind of careful. We're using formulas to show our rule, and then we also have functions that are functions of our problems here. So I'm going to go like this. The derivative is, and following the rule here, it's going to be the first function by itself, no changes to x. Then we're going to take the derivative of g. So let me go like this over here. It's this plus this. So I just did that. I just wrote the first function. I take derivative of g of x, but g of x is just e to the x. That's it. Okay, cool. Plus sign. Then I have g to the x, which is itself again. And then I have the derivative of x, which is this little piece right here. Derivative of x is 1. So there it is. The derivative of those two functions added together gives us this. All right, what's so special is that this formula gives us the slope at every single point of the other formula. Let's try this here. Let's try this two different ways. I think this would be helpful to try two different ways here. So B. It is. Let's do this here. So 2x plus 4 and 3x minus 1. There it is. I'm going to get the derivative of this. But before we do that, let's do this here. Let's do it two different ways. One is going to be, we're going to FOIL all this out first and then take the derivative. The other one is we're going to follow the rule. So let's do it two different ways. So first things first is, in fact, that's probably easier to do it like this. Let me do it like this. Let me do it by, we're going to do B, and then we're going to do a star B. I like star B. So basically, we're doing the exact same problem, just a different way. That's all. So first things first, before we do anything else, I'm going to multiply this out. Can you guys FOIL this out? Here, this will be 6x squared. This would be a minus 2x minus plus 12x, so plus 10x minus 4. So now let's take a derivative. So this guy would be 12x plus 10. That's pretty cool. Okay, so now let's take the derivative based upon our product rule and we'll see if we get the same thing. Now these are easy problems here, that's why. So according to our product rule is we keep the first function exactly the same, no change. We take derivative of second function. What is the derivative of 3x minus 1? Just 3. Okay, plus sign goes in. Then what we do is we put the second function down. And then we take the derivative of the first function, derivative of 2x plus 4. And it's 2. Okay. And then let's do this here. Let's simplify this out. So this becomes a 6x plus 12. This becomes 6x minus 2. And the result is 12x plus 10. Are we good? Both ways now give us the same exact result. That is cool. Okay, let me see what other ones we could try here. All right, and C, just to introduce us to more variables here. I'm going to go with y equals 4 2 r e to the r. All yours there. All right, hope you guys tried it yourself here. I'm gonna try myself here as well. Okay, let's see. This thing is, so notice there's no x's, there are r's everywhere, so I assume r is my variable now. Derivative is the first function to be exactly the same, no change whatsoever, multiplied by the derivative of my second function, e to the r, still e to the r, plus my second function, multiplied by the derivative of my first function here. So in this case, it's 3 times 4 is 12. So 12 r to the third minus 2. Now the question is, do we simplify that? Yeah, we can simplify that out, even though, we could do. You notice that both of them have e to the r. We can actually pull out an e to the r. And what's left over is 3r to the fourth minus 2r plus 12r cubed minus 2. Really, that's all that's there. So put it in nice order. I guess put an order of exponents. So there was nothing. There was no common terms here. And we'll probably just leave it just like that. That's fine. All right, that is the product rule. So we have figured out a way to take derivatives of things that are multiplying together. That's cool. Next is something called the quotient rule. What happens if things are being divided? So this one's going to be a little tough one here, and I'm running low on time as well here. So let's go with it here. So this is going to be, what's the derivative of two functions that are being divided? All right, what is the equation here? Let's go with it here. So what we do is we take the bottom, get my pen's not working. Okay, there it is. The bottom function times the derivative of my top function minus my top function derivative of my bottom function over my bottom function being squared. Oof. Okay, there it is. That is how we deal with derivatives of two functions that are being divided. Let you guys copy that down. All right, let's try a few as time is a little bit running out. Next slide here. I think we're on example 3 now. And it is find the derivative. On Friday, when we come back together, I will take some time to do homework questions. I'll see if we can wrap up all the way up to 3.2, and then we'll see maybe we can get to 3.3. All right, so here it is. We're going to do some fun derivatives here. Let's go with it. Here's what I need to do. Y is equal to, I need to figure out the derivative of this guy. Is x squared plus x minus 2 over x squared plus 6. Is it x squared? Just check. X cubed. Let's go with x cubed on this one. X cubed. There's a 3 there. Plus 6. All right, you guys to try it first. Go for it. All right, so all this section is about really is just understanding the product rule, things that are being multiplied together, how we take derivatives of those, and quotient rule, when things are divided, how do we take derivatives of those? All right, I'm going to go for it here. So the derivative is, again, it just takes a little practice. Once you sort of first see it, you're like, what is this? It's so many things here. But once you do it 5, 6, 7 times, it becomes almost second nature here. Okay, so let's go with it here. So according to my formula, as I do, I take the bottom function and I just rewrite it. Then what I do is I take the derivative of my top function. So derivative of this guy. That'll be a 2x plus 1. Ooh, we have a minus sign this time. Hopefully make sure. Did I put a minus sign? Yeah, okay, there's a minus sign right there. Now it's the top function. And now we have the derivative of the bottom function, which is going to be 3x squared all over the bottom function being squared. That is it. And do we simplify? Yes, we have to simplify still. Oh boy. So here it is. We got ourselves that right there. And we're going to have to move all the stuff around. So x cubed times 2x. That would make a 2x to the fourth plus x cubed plus 12x plus 6. Now, kind of careful here because there's a minus sign. And we're negating all of this stuff right over here. So let's do that first, and then we'll kind of plug it into here. So the minus sign is still here. And if I were to multiply this out, all this stuff would be 3x to the fourth plus 3x to the third, looks like. Yep. Minus 6x squared. And when I write it down, because the minus sign is still here, this would be a minus, need more space here, minus 3x to the fourth minus 3x cubed plus 6x squared. Okay, running out of room here. Let's see if I can squeeze it all into here. So the final answer is, and I'm going to leave it just like that. This is going to be this to the second. And I'm going to have to combine like terms here. So I have a 2x to the fourth minus 3x to the fourth makes negative x to the fourth. X cubed, which makes a minus 2x cubed. There's only an x squared, so that's a 6x squared, perfecto, plus 12x plus 6. Okay, there it is. There's your answer. It's a little long, but that is the answer with the quotients. All right, let's do one more. After you practice this a few times, it does become a lot easier. All right. Yeah, let's deal with that. That would be good. So B. I'll let you guys try it first here. I need to know the derivative of this. Of course, I'm going to throw an e to the x in there somewhere. That's just what makes it fun. All right, let you guys get started first. Go. All right, let me start it as well here. So I got the derivative is, all right, the bottom function. Derivative of the top, which is itself. E to the x derivative of e to the x is e to the x minus sign. The bottom function and derivative of the bottom, which makes a 2x at this point over the original denominator squared. There it is. All right, and with these, notice I'm going to do the same thing that I did with the product rule. I have 2 e to the x's, so I might as well actually take them out and see what's left over. So what I have left over is a 1 plus x squared minus 2x over 1 plus x squared squared. Okay, so hold on, maybe just a little bit more stuff here. If I write this in order, I have myself x squared minus 2x plus 1. And that is a correct answer. In fact, that's a correct answer. That's a correct answer. And then you can kind of see this also is a correct answer. All of them will be just fine. But can you guys give me what this factors down into x squared minus 2x plus 1. X minus 1. There it is. X squared to the second power. And there is our derivative. Okay, let's do one more if we have time. If there's still time there. How about this? Do you guys remember our little, let me go back over here. Remember we had to take a derivative of this guy for homework. In fact, no, let's do this here. I'm going to go right in my notes, back in my notes. Sorry, going back and forth here. Let's see. This one, x squared plus 5x plus 8 over square root of x. So 5/8 square root. All right, let's do this one. This was very similar to the homework question. And we'll take the derivative of it. So again, that's what is our formula. It's the bottom function times the derivative of the top, which is 2x plus 5 minus the top. And now we have derivative of the bottom. And then if you need to do it off to the side, that's fine. Like what's the derivative of x to the 1/2? It'd be 1/2 x to the negative 1/2, or 1/2 root x. Okay. So 1/2 root x goes here over this guy being squared. Is that right? Okay. So now let's deal with exponents here. So you guys know that this is x to the 1/2. And if it's times 2, this becomes 2x to the 3/2. This becomes x to the 1/2. Oof, we got some work ahead of us here. So if I multiply this and this, gets us 1/2. That's 2, so 3/2 plus 5/2. That's a to the 1/2 plus, and that's just going to be 4 with the square root of x on the bottom. There it is, all over x itself. All right, notice these guys become a little more complicated. Is that right? And they're like, whoa, yeah, we're going to stop here. So now the question is this. Sometimes you want to use the quotient rule, and sometimes you don't. And sometimes you want to just factor it out yourself. And sometimes you want to simplify things out first. So it just depends. Do you want to do quotient rule first? Do you want to simplify first? Depends on the circumstance. Depends if you can simplify. Like which one is faster? Which one's the faster way of doing it? Right? So eventually, yes, you would get to the same answer that we got earlier. But we're running out of time here, so I'm going to stop. And then I wish you guys the rest of a good day. And see you on Friday.